All right, welcome back. Let's talk about our largest organ we have, the skin. Below here you got a few concepts that we'll learn about, but if you print it out, it's good to keep that handy. Let's just go through it. The integumentary system is the proper word for your skin as a system. Skin covers the external surface of our body. You can touch. When you touch yourself, you're touching skin first. The thing you touch first is the epidermis. Epi means on top, so that's the uppermost layer, the epidermis. And dermis means skin. Underneath that, we have a dermis. And then if we get through a dermis, deeper even, we have a fat layer. That's called the subcutaneous fat layer, which keeps us warm. The epidermis is mainly made up of stratified, squamous, keratinized epithelium. That's the tissue type. So let's take that apart. Stratified means multiple layers as compared to simple layers. We remember epithelial tissue comes in two forms, single layers or multiple layers. Stratified is multiple layers. That makes sense because the multiple layers are often, the qualities are here for protection. And so the skin is our outermost organ. We always bump into things. We need a lot of those cells to protect us. Squamous is the word used for flat cells. It's a cell type. We have cuboidal, columnar, and we also have squamous cells. Those look like fried eggs. They're flat with the nucleus in the middle. And then keratinized refers to the fact that keratin is a protein that makes us hard and waterproof. So the fact is that those cells have a lot of keratin in it. And then epithelial just tells us it's not connective tissue or nervous tissue or muscle tissue. It's epithelial tissue. So again, look at the keratin. That's protein that makes the skin, but also the hair and the nail, hard and waterproof. It's basically, I often call it the leathering agent in our skin. So, the epidermis first. The epidermis is made up of 4 cellular layers, with the exception of the palms of the hands and the soles of the feet, where we have an extra layer. And as we know with anatomy and physiology, we have many difficult new words, so let's go through some of those. The lowest layer is the stratum. Stratum means layer. Germinativum, or sometimes they call it the stratum basale. That's right at the base between the dermis and the epidermis. So that's the first cell layer. Those cells divide constantly. And when we have division, we have 2 daughter cells coming out of the cell division, and then one of those daughter cells migrates towards the surface. And what happens at that point, we start increasing this protein keratin. So we have a pre-keratin content increase. That's known as the stratum spinosum, because the cells have little spine-looking things on them, and so they call them spinosum. And then as the cell further are pushed towards the top, they deteriorate, they start dying, and more granules appear in the cytoplasm, and so they call that stratum granulosum, because there is granules showing. Then in the palms of the hands and the soles of the feet, we have an extra layer, and in that area, the nucleus and the cell membranes disappear, and so we call that the stratum lucidum, because we see through it, it's lucid. And then a top layer in all skin is basically a hard layer of dead cells, of scales that then can be shed from the body. So that's the stratum corneum, keratinized scales that can shed from the body. So you bump into something, a few cells fluff off your body. You don't see them, they're too small, but that way you don't have to be scraped. It's just easier for the body to deal with it that way. Great protection now. When we look at the cells that we find in the integumentary system, the main cell type, or in the epidermis, sorry, the main cell type is the keratinocytes. That's the ones we just described, the ones with the keratin in them, the ones that make the skin be leather. So you have a leather jacket on at some point. Other cells include Merkel cells, and those are mechanoreceptors that are mostly found in areas where it's very sensitive, like fingertips that we have. So they're Merkel cells. I know those names. Melanocytes are cells that have long processes and contain pigment, the melanin. And that pigment forms around the basic cell layer, protecting the basic cell layer from UV radiation. So it's like the pigment is umbrellas that the sun rays don't come down in and damage those cells. So that's great. So when we get darker, then we have more melanin because the sunlight reacts to it. Or the melanocytes react to the sunlight. And then we got the Langerhans cells, and those are long john cells, or I call them long johns because Langerhans in English means long john. And those are antigen presenting macrophages. We just talked about the immune system. The antigen presenting macrophages. Macrophages are big eaters, so they pick something up that's foreign, that shouldn't be there. They digest it, and then they take the fragment that is an indicator of a pathogen or something that we don't want, called an antigen, and they present that with their own MHC, that major histocompatibility complex, and that indicates to other cells that, oops, this cell is infected, something is wrong, let's go to it and figure it out. So it helps the immune reaction starting up. When we then get to the dermis gives the skin its resistance to tearing and makes it plastic, which is its ability to reform. It contains a thick network of collagen fibers, but also elastic fibers. When we deeper look into it, we have a papillary layer, and that's the top layer that anchors the dermis to the deeper structures. So the papillary layer is actually a layer that is created with little hills. So they're little papillas going up and down. And what that does, it increases the surface area. So that way the skin, the epidermis is more attached, or firmly attached to the underlying layer than if it were just a straight surface. So we have more surface area. The other thing is, there is no nutrients, there is no blood supply in an epidermis because it's epithelial tissue. So all the nutrients that we get are coming from the dermis, and they are diffused into the epidermis. The other thing that works similar with that is nerve supply. Most of the nerve supply is in the dermis. We have a few of these cells, like we talked about the Merkel cells, but most of that is deeper. And in the deeper dermis, we have many more receptors. Then after the papillary layer, when we reach deeper, we have the reticular layer, and the reticular layer anchors the dermis to the subcutaneous fat layer. A lot of reticular fibers in that layer. Let's look at some functions that skin can have. Skin protects us against mechanical, but also thermal radiation as well as chemical damage. The keratin protein in that, for that function, is the key ingredient. The immune function, we talked about that. Skin is a boundary. So skin forms the first line of defense by a mechanical boundary. Temperature. The skin has, the dermis has blood vessels in it, and so depending on the constriction or the dilation of those vessels will determine how much blood flows on the surface of the body, will determine how much heat will be radiated off. So if it's hot, we're going to bring those vessels to the surface so they radiate off heat. If it's cold, we constrict those vessels and preserve the warmth inside the body so we don't radiate off heat. The other way with temperature is when we're sweating. And sweating is the way for us to cool off a system, because when we take sweat, the water that holds warmth will be pushed to the surface of the skin and it will be radiating off that way, evaporating off. Another thing with the skin is water balance, because the skin prevents, the epidermis prevents water loss. It keeps everything on the inside. It's kind of like the boundary between this dry world on the outside and the inside that's like the ocean, like we come from the ocean, so the inside still has ocean qualities. We need to be careful. Sweat is salty and it contains a lot of electrolytes, which are ions that influence many body functions. So if we're sweating a lot and we're just replacing with water only without any minerals in them, we're going to be depleting our system. So that's good to know. That's where Gatorade comes in. for example. But obviously I prefer a drink with less sugar in it than Gatorade, but the ions in it are very helpful. Skin also has a sensory function. Skin has a lot of receptors for pain. They're nociceptor, N-O-C-I receptors. They tell us that there's a danger around. We have touch receptor, we have temperature receptors, we have pressure receptors. So touch is different than pressure. Deep pressure elicits different receptors than just when we touch the skin. And often people, like autistic people, for example, they like to have a deep, deep hug, so or lie under mattresses. So when we have a pressure sensor be activated and released, that can give us a sense of calmness. Animals behave that way too. And then, of course, skin has a function communication, because if our skin blushes or turns pale, that sort of tells us what's going on the inside of that person a little bit. We look at the skin, we have appendages, we have glands, we have sweat glands, which secrete a sweat, an acidic sweat, which regulates body temperature, but also gives us a protective coat for bacterial growth, because it's acidic a little bit. And then the other thing is your dog likes to lick it, most likely because it's salty. I know, I always think my dog loves me, but it's because I'm salty. Then we have sebaceous glands, and the sebaceous glands are sort of your natural oil glands. They are rich in fatty acids, and they help our skin, make our skin pliable and provide a gloss to the hair. They always come up next to a hair follicle, which goes next. We have hair. Hair provides heat and touch sensation for the body. The hair shaft is enclosed by a hair follicle, which then a sebaceous gland opens into. An erector pili muscle is a little muscle that is attached to the hair, but is also attached to the skin. And when that muscle contracts, our hair that normally comes out in an angle will stand up straight. And so we will then have goosebumps created, because the erector pili muscle is pulling on the skin to straighten up that hair. And by the way, we straighten up the hair because there might be a danger coming, and an animal needs to look bigger. You'll see that in a cat when the fur on the neck raises up. But the other reason is when we have the hair standing up, it creates more heat. It creates a more fluffy coat. The hair bulb, which is the bottom part, that's sort of the growing end of the hair, forms the deep end of the hair, and then in there is a hair papilla, which is a place where we contain blood vessel as well as some nerve that feeds and grows the hair. Nails are another skin appendage. Why do we have nails? Because they're specialized function, they're very specialized, and they look quite awkward in some ways. But we have nails because when we grip something and we only have a fluffy thing covering the bone, we don't have an ability to be very fine, manipulating things finely with gripping. So the nail gives us a backstop, so to speak. A nail plate is anchored in a nail bed, which is the skin underneath it. So do not pull that part off, because that hurts a lot. And that epithelial tissue grows constantly forward. And then, of course, we know that because we have to clip the nail plate up at some point. So here's the text. The nail protects the terminal phalanges of the finger and toes, forming a backstop for pressure exerted against the soft tissue, the soft part, while grabbing an item. So that's a very helpful thing, very useful. There you go.